I got the Emerson 336 off to the side right now. We got too many things going on. Good evening. Well, I'm kind of crowded on the bench here, as you can plainly see. I haven't done any more with the tube testing since the last video I made about that. I've got the AOE on the floor over here. I've got the Bakelite cabinet for the Emerson 336 on the floor over here. I got the box of tubes on the floor over here, and I have to keep moving it to get out my door to shop. And I still got to test these tubes here. And I got a radio over here, which is the one that I said I was going to work on later on, and I will be doing that in the future. It's a Hallicrafters S107. Sorry, I'm having a bad throat day today. I'll take you over here. This had some rust on it, so I went to my hardware store today and I got some aluminum paint, oil-based paint, and painted the chassis, and it's not a great job. I did it by hand. I did not buy a spray can. The back of the radio was all rusted all the way through here, and I started out on the skirting, on the lower part of the skirting only. It was quite rusty, and I used 80 grit paper, and then I went to 220, and I got it pretty smooth where I didn't need navel jelly. But on the inside of the cabinet on the bottom, just like the Gonset radio, but not as bad, the rear of the inside of this cabinet was all rusty. And I had to sand most of that off, used navel jelly, and I let the navel jelly sit on there for about 10-15 minutes, rinsed it off under the spigot, wiped it down good, put the second coat on, another 15-20 minutes, rinsed that off, dried it up really good, let it sit out in the sun and make sure it was dry, took some nice clean paper towels and went all over on the inside. This is only on the bottom and on about an inch on the rear apron where these jacks are and everything on there. Paint is still sticky a little bit. And then I let an hour go by. Everything was totally dry. And then I hit with 2 coats of self-etching primer, the one I get from Harbor Freight, the gray. That dried fairly quick, and then about a half hour later I got some Rust-Oleum gray, which is the same paint that I used on the Gonset cabinet. And I did just the inside, not the outside of this. The original filter cap is fine. This is not going to be done on video now. It does work. This is the speaker. It happens to be a realistic speaker that I took out of here because the wires were soldered on the terminal and I couldn't reach inside the cabinet good to get my soldering iron on, and the leads just barely reached. So I added some wire, soldered it on. That's why I took the speaker out, so I can see what I'm doing. And then when I connect this back up, I'm going to put 2 small wire nuts on here. So if the chassis has to come out, I'll just twist them and put a little wire nut on each one. That should be okay. And these are long enough where I can work with it. I can shorten these if I need to. The whole chassis was kind of like rusted, but not real bad, all around here, all around the IF cans, all around the filter can, and a little bit around the transformer. And you can see brush marks. I used a foam brush. The dilemma is, I got two dilemmas on this thing. The radio works. It seems to be dead, totally dead, no hissing or anything, above 10 megacycles. So the band, it goes up to 31 megacycles, it's totally dead. And all these tubes, this is a new 6C4 oscillator tube that I got from Bob Dubush. 6 BA6s. One was good, the other two were bad. Well, they weren't bad. They were, one was a little bit weak. The other one had a little bit erratic grid emission. So I got two 6 BA6s and a 6C4 from Bob Dubush. Although the 6C4 was in there tests good, I figured, well, maybe it was a little dead on the upper end because of the oscillator tube. So you want a good oscillator. And this is a 6BA6. So these are all good. All these tubes test good. This is a 6H6. And that's good. The audio output tube is good. But my dilemma is this. This is your band spread here. And this is driving me nuts. No matter how I bend this plate here is shorting out when I get down to about here. I hope I'm on camera. I was looking at the, not looking in the camera. And then it cuts out. It shorts out. And I take and I bend it over a little bit because I can feel it. I should really plug this in. While that's heating up, see this frayed right here? I'm sorry, I don't have a pointer here. I'll have to satisfy using my finger. It's all frayed here, and when it gets into that area, the dial don't like to move. I am not. See, it stops. It just keeps slipping. See, I'm turning the dial, but nothing's happening here. That's one dilemma. The other one is here. So the only way I can make that go is to go in there and push down on the tuning capacitor, give it a little help, get past that spot. There's nothing I can do. I cannot do this dial cord. I'm not even going to attempt it. I will fail and I have no radio at all. Get a lot of noise in the shop, see? Nothing's happening here. It gets past this bad spot. It'll be all right. There it goes. All right, I got just a little wire in here, and it's getting the light interference and everything else. All right, so that I can't deal with. There's nothing I can do. When it breaks off, it's gone. There's nothing I can do about it. I can't ship this to somebody to have the dial string done. But I do have an idea, and I'll throw it to you in a minute here. Now listen to the AM when I tune the band spread. The station's going to go away, but the radio will go dead because this thing was short out. So I'm going to turn the volume up. I'm going to turn the band spread. I'm going to close it in. Hear it? It's shorted out. There's nothing I can do. It shorts out. And I bent this thing every which way but loose. Remember that movie? And unfortunately, that's your 48 to... 54 megacycle, your 6 meter right here. That's used for your tuning as well as the band spread. So when you get down to around 48, it shorts out. See, it's dead now. So you're not going to get anything on the band at all. See? So I tried everything. Let me turn that down. I tried everything. It seems to be this one here. I bend it this way, and there was a point where it was shorting out almost all the way. It was shorting out up here. Let me put this back up. See, it's fine up through here. It's not shorting it out. There's a single plate here. I don't know if you can see it on the video. And a single plate here. Alright. So, I think we may have to live with that because I can't do anything with it. My eyes don't permit me to look down in there to see it. So I have to guess.
A lot of people inside and outside.
Wants to go to the right. Okay? Because when you gently touch it to the left, it dies out. So the plate needs to be bent that way. No matter what I do, it still shorts out. So we got to live with that.
Now seeking to avoid public.
Okay, so we'll turn this volume down. All right. I'm not going to work on this right away. I just painted the entire chassis today, a couple hours ago, with the aluminum paint because it had a lot of little rust dots all over, but nothing really bad. But I can't make the chassis look good like a lot of the guys, like Ron C. in Florida there. He does a fantastic job on his stuff. But I can't do work like that. I'm lucky I can do what I do here. So, what I want to do here, I'm going to pass it to you guys and see what you think. If you look down here, and you probably will not be able to see it on this camera. Let me stop this camera a minute. I get a magnifier here. I was going to get the big Sony out, but it's too much editing, too long of rendering, I should say. So there's some hairs sticking out. In this bad spot on the dial cord, it's held together by maybe one thread in that particular area. You might be able to see the little piece, and I'm holding the camera and I can't do everything. You might be able to see the little string going around. Let me go this way. It's not moving. That's why I'm turning it. Let's see if I can. It takes two hands to do this. Here it goes. All right. Can you see that little? Let me get my needle nose here. I don't have a screwdriver handy. See that? Right there. See that little hair sticking out? Well, there's a whole bunch of them in here. I was thinking of trying to trim it off, but I think I'll end up cutting the cord. So what I'm thinking of doing is winding this around so it maybe, let me see if this will come up. Stuck again. Hang on a minute, I got to do this manually with two hands. All right, you see all those hairs sticking out there? I'm sorry, I'm getting the light blinding the camera and everything else there. All right. All this. What I'm thinking of doing, and I don't know if it's going to work, I'll remove this tube here. Radio turned off, of course. I was thinking of putting some Duco cement on here. Coat this with Duco cement. That's that glue I swear by. Let it dry good. It may add some body to the dial cord. And very gently, maybe before doing that, try to trim off these loose hairs. But it's a microscopic job for my bad eyes. But once this dial cord snaps, I'm dead in the water, totally. And this radio will be a shelf queen also. Because if the dial don't work, there's nothing I can do. I got the instructions for it, and the dial string instructions, but I can't deal with this. This is worse than doing a table radio. So right now you can see the pointers moving. All right. Now another thing too. Again, I'm using the wrong camera to get close-ups. You see this pulley right here, all right? But there's another pulley that does nothing over here. See it? It's not connected. Nothing's on it. But anyways, that's going to be a project. Need two hands. That plugs up very hard to get out of the wall. Hey, this aluminum paint takes a long time to dry. It's still sticky. You see all these red caps here? Somewhere I read that they're tiny, what they call tiny chief. There's one right there. This is loaded with tiny chiefs. I heard, but I can't remember what video it was. But from what I understand, those caps are usually good. They're not like the bumblebee caps. And everything seems to be working in this radio, except it's pretty dead over 10 megahertz, or 10 megacycles, I like to use the term. I'm going to let this dry all the way. Let me know what you think about maybe putting some, work some glue in with my finger on up and down this, and try to get some of this hairs out of here. See it? Get a little hair sticking out. Trim that off. Give it a haircut. It's only in this area. I wouldn't even attempt to cut the cord and put a knot in it, because then you got a knot that's going to go over there, and that'll really have a hard time going through this. I think the problem is this, and in addition to that, this part of the cord right here and here is super thin. It's like half the diameter, so there's not much left of the cord. The rest of it is fine. I looked all through here and it looks good. It's just here. It's going to break. It's just a matter of time. Not if, but when. So, I got my work cut out for me. Now, I want to mention something that I found out, and I should know this, but didn't. Well, I did and I didn't. The Emerson 336 uses a 35Z5 rectifier, as I mentioned, and I also said that I needed one. I found out I had asked a question on the Antique Radio forum. I put a resistor across the pilot light. The pilot light blew out. on that radio, because the tap, your 35Z5 has a tap between pins 2 and 3. And I believe 7 is the filament. 2, 3, and 7. So in the tube tester, the 35Z5 lit in here. It did not light in the B&K 606 as I was showing you when I was testing the tubes in the Emerson. But in this tester it did. I got the tube back in there again. Thanks to the guys at the Antique Radio Forum, they're very knowledgeable. The mystery of the Type 35Z5 open filament, which I printed out. It's from an old publication. And you may not be able to see that. I'm sure you can't. Your pilot light it acts as a fuse, but so does your section of the filament between pins 2 and 3 of the 35Z5. Now, if you have a radio that does not have a pilot light, you can just jump out pins 2 and 3. As a matter of fact, Radio TV Phono not just coincidentally happens to have a radio that he was doing, a real old junker, and he just jumped out the pins 2 and 3. And even if you have a radio with a pilot light, you jump out pins 2 and 3, the pilot light will no longer light. But your radio will function. In other words, don't toss your 35Z5 out unless the whole thing is burnt out. If the tap between pins 2 and 3 is burned out, save it for a radio that does not have a pilot light. And if your radio requires pin 2 to be hooked up, just move it to pin 3 or vice versa in order to get the rest of it lit. Because you've got it, the tap actually is like a resistor, and there's a voltage drop across that resistor, and your pilot light lights off of that. However, if the tap is burnt out, your full current from your filament as well as your B+ is across that bulb, and the voltage goes up. And I think the it's a 150 mil bulb. You can put a 44 in there, which I think is a 300 milliampere bulb, but you're still stressing the bulb by putting 8 or 9 volts or more across it. So as I set that radio, I did it off camera, on the Variac, and when I got to about 65 volts, that pilot light was lighting pretty bright. Whereas I cranked it up higher, the pilot light got brighter. When I got up to 118 volts, the radio was playing fine. The Emerson was playing fine. I went to start peaking it up, and bang, it went out. Come to find out, the pilot light burnt out. But I didn't know that right away. I thought the 35Z5 gave up the ghost, but it didn't. Only the tap was gone. So here they're recommending, and it's a long article, and I'm a slow reader. Yeah. Let me get out. Let me get out to read it, that Polish hot dog Steve sent me there last year. this is a nice lighted light. I don't need the lighted feature. This gives good magnification, but I find myself using a little one because I can get in there better. This is a little awkward, and I'm already banging into things. Okay, the mystery of the 35Z5 open filament. Sam's Serviceman has been going around for some time now. Mighty short fingernails, and it really bothers him no end because the nails come in pretty handy to strip the insulation from the wires. He left wire strippers at home. Alright, let me just go on. There's a silly story here with it. Alright, I'm going to try to read from this. Okay. AC/DC sets. There was trouble with the various tubes in the string which turned out to be an open filament, and he had to replace a lot of type 1N5s in AC/DC battery portables. I don't know what a 1N5 has to do with the 35Z5, but anyways, let's see if we can throw a little light on Sam's filament difficulties one at a time. Alright, figure 1 shows a circuit employed in using types 35Z5, 45Z5 in typical receivers. Types 35Z5 and 45Z5s are similar to other half-wave rectifiers, closely spaced rectifier tubes, with the exception of the heater has a tap brought out for the pilot light at a point at which 7.5 volts from one end of the heater when rated heater voltage is applied and only heater current flows. Therefore, pilot light can be placed across this tapped section, which eliminates the necessity of a ballast resistor as is required to secure the pilot lamp voltage when using other type rectifiers. However, in order to increase the brilliancy of the pilot lamp, it is current design practice to connect the rectifier plate also to the heater tap so that the total plate current of the receiver will pass through the pilot lamp. This is why panel lamps flicker on strong signals. I never noticed that. None of mine flicker. Because the plate current varies with the signal strength, that's understandable, and normally the amount of plate current passing through the pilot will also vary, and I got a tip of my nose itching. Okay, so we got a diagram here showing pilot lamp, as I showed you, across the tap, which is intact and not blown out. Okay, we'll continue on here. Sam has also noticed that the pilot lamp in these receivers is like a lighthouse when first turned on. Yes, they do. This was done to the fact that when the tube filaments are cold, yes, the resistance is low, they would be, when they first turned on, the current drawn by the series string filaments would be very high as the resistance of the filaments were very low. But when the filaments become hot, their resistance increases and the current is reduced. And as the pilot lamp is shunted across a section of the filament, there is a large voltage drop across the pilot lamp caused by the high current of the cold tubes. And it is this high voltage drop that can damage the pilot lamp and cause it to open. As soon as the tubes are warm, this voltage decreases and the pilot lamp hardly lights until plate current starts to flow. Then the pilot comes up to normal brilliance. Now look at figure 2 and see what would happen if the pilot lamp was not replaced. I know it's difficult because I'm not showing you the diagram. Remember that the pilot lamp acts as a shunt across section of the rectifier filament, and keep in mind that the total plate current of the receiver also passes through this shunted section. Therefore, it can be seen from figure 2 that with a missing or burnt out pilot lamp, the tap section of the rectifier filament must complete the circuit for the plate current, carrying in this way both the rectifier and the filament currents. The filament is designed to carry 150 milliamperes, but the plate current is now added to this, and it is normally around 50 mils. We have a total of 200 milliamperes passing through the tap section, thus subjecting the tube to a considerable power overload which will shorten its life. In other words, there is approximately 15 volts across a section that is designed to have only 7.5 volts on the pilot light. Now, should the receiver be turned off and on without allowing the tubes to cool, another problem presents itself, which generally causes the filament of the tapped section to burn out. This problem is called on and off cycling and depends a great deal upon the capacity of the input filter capacitor, or condenser as they call it here. On and off cycling can be illustrated by the following example. And she goes on to a little story here. Mrs. Smith had not replaced the pilot lamp in her receiver, and one evening she thought she heard a telephone ringing, so she turned the page in the book. Sorry about this. She turned off her radio for an instant to make sure the telephone was quiet. So she turned on the set again, and the set failed to work. The set did not work because when Mrs. Smith switched off the current, the cathodes of the tube were hot and had consumed all of the voltage that was stored in the electrolytic filter condensers. Then the next instant, the current was turned on again, and the rectifier cathode, still being hot, and allowed current to flow to the filter condensers to become charged again. The current consumed in charging the input filter condenser is very high, and the larger the capacity, the higher it is. This current is plate current and must pass through the tapped section of the rectifier filament, thereby adding to the filament current and causing it to be high enough to burn out the filament tap. It often happens that this same charging current is high enough to exceed the peak plate current limit of the rectifier, thereby causing the cathode tab to melt. The melted cathode in turn may short to the filament or plate, causing AC voltage to be applied across the filter condenser, which will certainly cause it to break down. To help prevent this difficulty, look at figure 3. All that is needed is a resistor shunted across the pilot lamp. This resistor not only prevents the high voltage surge from damaging the pilot lamp when the receiver is first turned on, but will, turn the page, okay, I didn't print that out, but it will absorb the current and it will not harm the tube. Okay, so I experimented with that. I only had 120 ohm, one of those resistors I bought at Jan Electronics. I had a 120 ohm resistor, and I put that across pins 2 and 3 of the 35Z5, and the radio worked. But the lamp got very bright when I went over 110 volts, so I need to crank that voltage, that resistance up a little bit. I don't have any high wattage resistors here in that range, so I got to go out and buy a resistor. So that radio is on hold. I still would like to get a 35Z5, but that 35Z5 is good. I'll just put a resistor across it. The resistor I had was 5 watts. It got warm, it didn't get hot. And then I'll bring the Emerson back on the bench, and then I can finally make the last part of that video. I think we're going to end this out now. I thought I'd share that information. So that's it, folks. So I'm going to, maybe I'll try putting some glue on it. Maybe I'll make the, of course I'll let it dry before I use it. Maybe it'll make the cord stronger and it might go through better. Maybe not. I don't know. It's a crazy idea, but I can't string a dial cord. Absolutely not. So, that's the story, folks. I'm going to get back to my tube testing. When the paint is dry on this, totally, it's dry enough for me to work on, but it's still tacky in places. And I did that several hours ago, but it's sticky in some places, not all places. So that concludes this video, folks. I'm going to end it now. You can see why I didn't bring out the big Sony. I would be here until midnight rendering it. Take care, everybody. I've been busy as a one-armed paper hanger with the crab, so I'm sorry. There's a lot of videos I have not watched, let alone comment. I'm way behind. I haven't even watched Buddy's, the Radio Shop's latest video. I've just been too busy, but I will. And a few others. I just haven't had a chance. I was up last night till about 10:30, and that's about the latest. I keep the computer on anyways. And I'll see if I can do something to get some comments, you know, reply to some of the comments and stuff, and watch a few more videos. Take care, everybody. Thanks for watching.